Sa frequency analysis, titingnan ko kung anong country ang naging top exporter of other oilseeds from year 2021 to year 2023. Dito sa Excel na to, meron akong tatlong data which is from year 2021 to year 2023. So first, dito muna tayo sa year 2023 na kung saan kukunin ko muna ang total ng lahat ng export value na meron ako sa countries from Asia. So I will be selecting the data. And after I get the total, para naman sa relative frequency, i-divide ko yung export value number 9 sa total na nakuha ko kanina. And then, ilalak ko lang yung formula by pressing F4. At after makuha ko ang relative frequency number 9, gagawin ko lang ulit ang same formula for Cambodia. The export value of Cambodia divided by the total. And then, I will lock the formula also. So, kapag nakuha ko ng dalawang relative frequency para sa Brunei at Cambodia, isa-select ko lang ang isa sa kanila at ito-double click para mag-copy at makuha ko yung relative frequency ng ibang country. Para naman sa percent frequency, i-multiply ko ng 100 ang nakuha kong relative frequency sa Brunei. So for example, yung relative frequency ng Brunei times 100 will be my percent frequency. Same process ulit for Cambodia, times 100 will be my percent frequency. So, select one data, double-click to copy. Ngayon, meron akong data set for 2023. Para malaman ko kung sino ang naging top exporter for this year, I will select this data set and then sort it out from smallest to largest. After that, I will be doing the same procedure or formula for year 2022 and year 2021. Pagkatapos ko masort ang data for the top exporter of other oilseeds from year 2021 to year 2023, dito natin makikita na ang bansang Myanmar ay naging top exporter from these years. For measure of central tendency, I have three data set here, wherein first, I will be finding what is the average annual export of vegetable oils from Brunei for the past 6 years, which is from year 2015 to year 2020. For getting the average, I will be getting the sum of all the export value from these years. And then, for manual computation, I will be getting also first the total of all the export value. And since I have 6 export value, for manual computation, I will be dividing it to 6 to get the average. For function, I will be using this formula, which is equals average. And then, I will be selecting the data set that I would like to get the average. So here, I have the average annual export of vegetable oils from Brunei for 6 years, and that would be 0.1. Sa pangalawang data set, dito naman, titingnan ko if does the median oil cakes export value to Indonesia better represent the trend compared to the mean. So, since alam naman natin kung paano nakukunin ang average, gagawin ko lang ulit ang same formula na ginawa ko for the first dataset na meron ako. For manual computation ng median, gagawin ko lamang is isa-sort ko yung data from smallest to largest. At pagkatapos ko masort ang data, itong dalawang export value, dahil meron akong 6, yung pangatlo at pang-apat na export value, kukunin ko ang total at i-divide ko sa 2. And this would be my median. For function naman, gagamitin ko itong formula, median, and then select the data set. So, to answer this question, does the median oil cakes export value to Indonesia better represent the trend compared to the mean? For me, based on the calculation na ginawa ko, yung mean mas better na nagre-represent ng trend compared sa median, since yung value ng mean is higher than the median. For my third data set, which export value occurs most often for butter and butter oil from Myanmar from year 2013 to year 2023? So for manual, dahil lang mo, tinitingnan nito kung ano bang value ang mas madalas na lumalabas sa dataset. So sa export value na meron ako, 0 ang most often na lumalabas sa export value ng Myanmar. And to confirm, I can use this function, which is mode.mult, and then I will select this data set. So here, it shows that the export value that occurs most often is 0 for butter and butter oil from Myanmar from year 2013 to year 2023. For analyzing distribution, I have here two data sets of sugar from countries of Singapore and Laos PDR. For Singapore, I have already computed the data sets. So to show with how I got those information, I will be using the data set for Laos PDR to show the computation. So for Laos PDR, here in my end, I will be checking what is the export range of sugar from Laos PDR from year 2013 to year 2023. So for checking the range, all you have to do is to subtract the highest value that you have in the data set and then the lowest value from that data set. So what I have here is year 2019, which is the highest export value, minus the lowest export value from year 2023. So I got 121.7 for the range. To check using the function, I will be using this equation, max, and then I will be selecting all this data set that I have, minus minimum or mean, and then I will select again the data set. So here I have also 121.7. For variance, for getting the variance of the value that I got here, I have already copied the export value from year 2013 to year 2023 from Laos PDR. This is for subtracting the mean from the export value. For variance, to get the data, I have here the export value copy on another table. So I will be subtracting the export value from the mean of all the export value, which is the total average. And then I will press F4 to lock. And then I will just select this column and then double click to copy. And then for getting the raise or the power of 2, I will be selecting this data, power, then this data, raised to 2, and then select, I will be double clicking to get the total. So once I have the total of this variance manual equation, I will be subtracting the total that I got here from the total number of variables, which is total of 11, that is from year 2013 to year 2023, minus 1. So I got 1,221.2. And to check, I will be using this function, var.s, and then I will be selecting this dataset to confirm. So I also got 1,221.2. Standard deviation, to get the manual equation, I will be raising this variance to the power of 1/2. So 34.9 is my standard deviation. For coefficient variation, you just have to divide the standard deviation that you have computed from the total average of all the export value, and that would be 57.39%. So to answer this question, what is the export range of sugar from Laos PDR from 2013 to year 2023 is 121.7. And on the second table set that I have here, the Singapore shows more stable export of sugar compared to Laos PDR from year 2013 to year 2023. So for this two data set, I have created the histogram, and based on the comparison, it shows that Laos PDR is much or more stable than the Singapore export value of sugar. distribution analysis. So here on the data set, I will be tracking what is the 85th percentile value of butter and butter oil exports to Thailand year 2013 to year 2023. To get that data, I will be using this equation, 85th divided by 100 times the total number of export value that I have, wherein I have 11 values plus 1. So 10.2, that would be this data, 3.258773, and to compute 3.258773 plus the 2 decimal and 85th percentile that I have computed, and then multiplied it by the 11 value in the data exports, 3.363411, minus the 10th value in the exports. So here, the 85th percentile value of butter and butter oil exports to Thailand year 2013 to year 2023 is 3.2797006. And for function, we can actually use this computation. And then, since we are looking for 85th, we will be putting 0.85 after selecting the data set that you will be checking. So 2.965369 is the 85th percentile INC. And then for exclusive, we will be using this function. Select again this dataset, and then 0.85 for the 85th percentile. So as you can see, it matches the data that we computed in manual computation. For checking the interquartile range, we will be getting that 25th, 50th, and 75th percentile, wherein that would be the same process with how we computed the 85th percentile. For interquartile range, to get the data, you just have to subtract the 1 quartile from the 3rd quartile. So 0.8495775 is the interquartile range. So on the second data set, which I have used the same equation that I did on the first data set to get the details. So on this one, I will be checking, do butter and butter oil exports to Ukraine have outlier years? So here, I have on the side this graph that shows Thailand and the Ukraine, wherein have outlier years. Measures of association. Here in this data set, I will be checking if do oil cakes to Indonesia and European Union move in the same direction over the years. So to check that, I will be using the covariance and the correlation coefficient. So I have here the export value from Asia, and then the export value of Europe from year 2013 to year 2023. So for manual computation to get the covariance, I will be subtracting each export value from the average of 2013 to year 2023 Indonesia export value. So that is 825.29. I will be selecting this to copy, and then I will be processing the same computation for Europe, wherein the export value of 2013 minus the average of all the export value from year 2013 to year 2023, 578.97. So after I get all this data, I will be getting their sum. And then after that, for covariance, once I get this data for Asia and Europe, I will be multiplying each export value from this country. And then after I multiply all this export value, I will also be getting their sum. So to get the covariance, I will be dividing this from the number of variables minus 1. So for manual computation, this data divided by the number of variables wherein I have 11 in total, 2013 to year 2023 minus 1. So here is my covariance for manual computation. For function, to get the covariance, I will be using this formula, covariance dot s, and then for RE1, I will be selecting this dataset from Asia, and then for RE2, I will be using the dataset from Europe. So as you can see, the covariance is 129,451.2. For correlation coefficient, manual computation, the covariance that we had computed will be divided from the product of the standard deviation of Asia and Europe. So I have here 537.18 times 296.30. So I have 0.81 for the correlation coefficient. And then to check for function, I will be using this formula, Corel. And then for RE1, I will be selecting again Asia. And then for RE2, I will be selecting the Europe dataset. So I also have 0.81. So with all this dataset, I have here this graph. And as you can see, the Indonesia and European Union did not move in the same direction throughout or over the years.
Alright, so for frequency analysis, our main focus is to identify which country is the top exporter of vegetable in 2023 and what percent of exports in 2023 came from that top exporter country. So using the relative frequency and the percent frequency, we can identify the two main tests. So in order to get the relative frequency, firstly, we have to get the summation of all our export values from year 2023. So our focus region is the Southeast Asia. As you can see, here is the countries in Southeast Asia. And these are the value export in year 2023. So the summation of all of the value export is 2,547.4. And then the relative frequency is the export value divided by the summation of all of your export frequency. Values here, which is J5. So we can select our cell of our export value divided by your sum or your total as your divisor. And to lock your divisor for all of your relative frequency across your Southeast Asia, just function F4 and then enter. Alright, so to copy the formula for remaining cell, you can drag it down or you can double click. Yeah. So to ensure that your relative frequency is accurate, the sum of your relative frequency must be equal to 1. So once you have the relative frequency, percent frequency on the other hand is the percent format of your relative frequency, which is just get the relative frequency and then transform it into percent form. So there are a lot of ways or formula in percent frequency, and you can also use the format percent in your Google spreadsheet or your Excel. So based on the export frequency of vegetables in Southeast Asia 2023, the top exporter of vegetables in 2023 is Thailand. As you can see here in highlighted portion of the table of the dataset. So Thailand had 58.15% of export in 2023. So aside from vegetables, we also have the rice in Southeast Asia, pulses, maize, and soya beans as my byproducts. So, alright, so for measures of central tendency, we need to get the mean, median, and mode. So in order to get the mean, we first have to get the summation of all our expert value from 2013 to 2023. So sum, and then all of your expert value per data set, and then that's it. And for mean, because this is an average, so we can get the total or the summation of all expert values divided by the count of the expert value, which is 11. Right. So for the function computation of the mean, we can easily get it to equals average, and then highlight the dataset of your expert value and then after. All right. So now we have the mean for annual export of rice in the Philippines from 2013 to 2023. So for test 2, that's the median vegetable export to Thailand, better represented right compared to the mean. So this is the same function of the total and the mean calculation from rice in the Philippines. So I will explaining how to get the median in manual function. So median in manual function is the middle value sorted list of numbers in dataset. So we need to sort our year and value in least to greatest. So this is already arranged from least to greatest, the LTF, to sort my dataset. So A to Z. So this is since it's 11 here, our median will be on the 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So our median is 2023, which is 1,481.30, which is right here. And then for the function, in order to ensure that our manual computation is correct or accurate, we can use the median. And then we need to highlight our expert value. And as you can see, it's the same. So our computation is correct. And for mode, which expert value occurs most often for soybeans in Brunei. So mode is the value that most appeared frequency in our given dataset. So this is the product is soybeans and country is Brunei. And visible here that the most common value is 0. So it appears third times in from 2013 to 2023. So I just input this here. But to ensure that our manual computation is correct, we can use the equals mode. And then we can highlight our expert value. Alright. Alright, so for measures of variability, our main focus is the range, variance, standard deviation, and coefficient variation. So I chose the Myanmar as my country in specific data set and then pulses as my product. But here I have gathered all the expert value from 2013 to 2023. So firstly, the range. Range is the highest minus lowest amount in our expert value. So as you can see, I have already arranged my expert value from least to greatest, and I just minus the greatest to least in our range. So I selected this cell because that is the highest expert value, and then the least expert value, and then enter. So for the manual function of our range is just simple maximum, and then select our data set. Minus minimum, select our data set. Alright, so for variance, first we have to get the total power. So how to get the total power? So variance manually is just expert value minus our mean, which is our average of expert value. So once we get the variance, we should get the power, which is power. And then open parentheses, our base, which is the variance, comma 2 for the exponent. Alright, that applies to all each expert value of each country. I mean each year. So once we have the total power, we can now proceed with the variance. So variance is the count of my total power divided by count of all expert year, which is total of 11 minus 1. Okay. So for function formula is just the var s variance, and then select my expert value data. Okay. So the manual function of standard deviation is power of our variance. So power of our base, and then 1 as exponent because it's square. And then for the function, simply as equal sign, square root, and then our variance, then enter. So now we have the standard deviation. To get the coefficient of variation, alright, so for our coefficient of variation, it is only the standard deviation over or divided by our average or mean, which is this one. So for Pins array is the set of values used to define intervals range from our dataset. So I based it on my expert value, which ranging from 700 to 100, 1,500. So I just use the 400, 600, 800, and count as 200. So to get the manual computation of our Pins array frequency, we can get it from array frequency. Array frequency. Select our expert value. Select our Pins array. And but the shortened formula of our frequency is just frequency, our expert value, and then our classes are the Pins array. With parentheses and then enter. So I made a histogram representation of our expert value of pulses of Nagnor in 2013-2023. And as you can see here, the expert value that ranging from 750 to 900 is has a count of 3, which are this expert value from 900 to 1050 is only 2, which is correct, and 1050 is only 1, 1050 to 2000 is only 1, and then 1200 to 1350 is only 1, which is right here. But 1350 and above is 4, which shows that our expectability is correct. So question is, does Malaysia shows more stable export of pulses than Myanmar in 2030 to 2033? By my histogram, I could tell, and by our expert value, I could tell that our Myanmar has more stability than Malaysia because the graph or the histogram shows the consistent increase or export value of Myanmar than Malaysia. So that's how we use the measures of variability in comparing the two countries' exports from their tier. Okay, so for distribution analysis, our main focus is to identify the 85th percentile of value of maize exports to Vietnam in 2013 to 2023, along with the exports of maize in South Africa in 2013 to 2023. So I have already arranged my year from ascending order of its export value. So as you can see, the export value of year 2013 has the least or the lowest amount, while on followed by 2015, 2016, and the biggest export value export is in 2020. And I also have the summation of all our export value using the function of sum, and then I just highlighted all my data set, along with the mean, which is the average of our export value. So for this table, Asia, Vietnam, percentile, manual, and the function of each percentile inclusion or exclusion. First, my main goal is to identify the 85 percentile. Right. So our percentile formula is 85 over 100 times 11, which is our count of expert value here. Okay, so this shows that in the 10th value of our expert value and along with the 11th value, that calls the 85% of our export analysis or the manual analysis. So to manually get the percentile of our 85 percentile, we need to get the 10th value of Vietnam, which is the 82, along with the 11th value, which is the 127. So I will show you quickly how to get the manual using the percentile that we already have. 0.2, which is the remainder of the percentile. But if the percentile does not have any remainder, then we can just use the 0. And then the 11 value. Okay, so that's how we calculate the manual. And as you can see, it matches the output of our percentile.ixp function. So in the functional analysis, I use the Excel's percentile.inc in the percentile ENC, and they gave 91.56 and 78.26, showing that the inclusive The exclusive function gives a slightly higher value since it's so in the functional analysis, I use Excel percentile that INC and percentile that EXC, and it gave 91.56 and 78.26, and showing that the EXC function gives a slightly higher value. Overall, the 85 percentile value for Vietnam is 91.56, meaning that the 85% of the MACE expert values are below that level. This suggests a steady growth trend with expert increasing gradually, especially after 2000. Okay, but aside from percentile, we also have the quartile analysis, which falls in 25 percentile, 50 percentile, and 75 percentile, and then it has the same formula than the 85 percentile. So just 35 divided by 100 times. You can see here the formula that I use, and then second quartile is 50 over 100, and of course, once we get their percentile, we will find the third or the percentile value in our expert value. As you can see here, the third expert value is in the 12.72, which is in 2016. Our sixth value is the 46, and ninth value is 73.9. Okay, so the interquartile range is the subtraction of our um so the interquartile range is the subtraction of our manual computation of our percentile or our quartile minus the least um computation of our percentile. Okay, so this is my plot. So this is my box plot on distribution of maize export to Vietnam. And moving forward to our export in Africa. So do maize export to Africa have earlier years. So basically, we can see that the export value in South Africa have significant higher than the export. Daddy, sabi ko sa inyo, nag-video ako, huwag niyo bigla-biglang tatawagin. So moving forward for the export in our maize to South Africa. So the maize export to South Africa have earlier years than the Vietnam. So as you can see, the export value in South Africa have significant higher than the export value in Vietnam. I also arrange my export value from ascending order from least to greatest, and then I get the total or the summation of all of my export value along with the mean or the average in our export value. So this is my percentile table in South Africa, which is Africa region. So for 85 percentile, I also get the 10.02 because it has the same formula of the 85. So from 10.2, I find the 10 expert value, which is the 106.80, along with the 11 value of our expert value. So in manual computation, we get 106 1206.80 plus our reminder, which is 0.2, and then multiply siya to the 11 value, which is the 1213, minus the 10 value again, which is the 1206. And then for the function, I use the percentile.inc, which is the inclusion of both endpoints for our given data set. Here, I given the data set of export in South Africa, and then the exponent, which is, the percentile, which is the 0.8. So for the EXC, which is the exclusion of endpoints, I use also the Excel function, which is the percentile ENC, and then I selected my data set and along with the percentile value, which is 0.8. So I also have here the 25 percentile, which is the first quartile, 15 percentile, second quartile, and then the 7th percentile, which is the quartile. So based on my computation, I have three. The percentile is in third estimate value. The second percentile is in 6, and then third percentile is in 9. So the manual computation, of course, we need to find the third value in our exponent. But since our percentile does not have any reminder, the 335 will be added. Alright, so this is my manual computation of my first exponent as an example. So I get the third year, which is the 2016, 335 plus 0 because our presenter does not have any reminder. And then our fourth value, which is 452, minus our third value, which is the 335 again. So it's likewise in the percentile, I use the Alright, so likewise in the percentile, I use the quartile.inc in function of Excel, and then here I use the quartile.inc to get the quarterly percentile of each um, quarter. So for interquartile range, of course, I just get the latest percentile minus the least percentile, or I need a quarter. For box plot, it shows the distribution of maize export from South Africa between 2013 to 2023. The blocks represent the middle 50% of the data from the first quarter, around 335, to the third quarter of 808.62. The line box indicates the median, which is about 566.23, and the whiskers extent of around 211.9 up to the maximum of near 1,230. So this is the whisker. So as shown, the distribution is slightly right skewed since the upper whisker is longer. There are higher expert values in later years, where no formal statistical years the upper suggests the unusual high export, especially in 2022 and 2023. So this reflects strong growth trend in South Africa maize export during that period. Okay, so for distribution of maize export to Vietnam, this is the whisker, which extends from 9.71 up to the previous, which is 127.32. Based on our question and our analysis, do maize exports to South Africa have about years? I can say that yes, because it has the strong and stable growth trend during their maize export. Then the Vietnam. Okay, so we are now on the methods of association, and I have here the export value of vegetables from Philippines and Korea to determine the export value or the direction of both countries throughout the year from 2013 to 2026. So firstly, I have to get the mean or the average of the Philippines and the South Korea. So average, and then I highlighted the export value of the Philippines as well as the Korea. And then this 4.43 is the standard deviation of all export amount of the Philippines. So it's SC, SDEV, and then highlight the cell of our export country and then enter. Same along with the Korea, because we need the standard deviation to calculate the correlation coefficient. Um, because we need the standard deviation to calculate the correlation coefficient of both countries. So X variable is our Philippines. Okay, so X variables is the Philippines and Y variables is the Korea. So this is the deviation of the Philippines. X initial is the export amount of the country per year, and then X variable is the mean or the average. So export minus mean is the deviation of the country. So this is the deviation of the Korean Republic from 2013 to 2026. And then here we have the deviation for each year to get the multiplication of both countries. So summing these products give us the covariance, which measures how the two variables move together in our manual calculation. Together. So multiplication of deviation of Philippines and South Korea is the result of this amount, and then this is the total or the summation of both countries. And this is the covariance of South Korea and the Philippines. So manual computation of covariance is the total or sum of both countries over n minus. And then for the function in our Excel, it's the covariance S and our data and our Y data. Okay, so for correlation coefficient is our covariance divided by our standard deviation from the Philippines and standard deviation from the Korean Republic. So for the function of the correlation coefficient, it, you can use the correlation and then highlight your x data, comma, and then your y data. So using either manual formula or Excel functions, the correlation coefficient comes out to 0.68, indicating a model positive relationship that suggests that over years, Philippines and Korean vegetable export generally moves in the same direction. So we use the line graph to show the trends over Philippines and Korean Republic. So the blue line represents the Philippines, and the pink line represents the Korea.
Sa frequency analysis, andito yung relative frequency at percent frequency. Dito, kailangan makompute yung total expert value over the year. Tapos, halimbawa yung Brunei, yung expert value niya, divide mo sa total para makuha mo yung relative frequency. Sa percent frequency naman, yung sa relative frequency ng Brunei, multiply mo sa 100 at alin yung magiging sagot sa percent frequency. At i-convert mo siya sa percentage. Dito naman sa measures of central tendency, dito naman yung mean, median, mode. Sa mean, para makuha natin yung mean, ito yung average. Kailangan mo yung total export value, tapos number ng data niya, kung ilan siya. Halimbawa dito, may 11 years. 11 years, i-divide mo yung total export value nun. At ayun, sa 11 years na yun, ayun magiging sagot sa mean. Sa median, kailangan mo siyang i-arrange ng smallest to largest para makita mo yung median. Dapat dito intact din pala ang yung step. Sa measures of variability naman, dito, andito ang range, variance, division, coefficient of variation. Ang range dito ang pinakamadali dahil kailangan mo lang hanapin yung total export value, yung pinakamataas na total export value at yung pinakamaliit. At mas mga variance, yung details ng export value at total niya is then the power of 2. Standard deviation, para solve mo ang standard deviation, kailangan ko lang i-root ang variance. Sa coefficient of variation naman, yung standard deviation over mean times 100. Solve, makuha mo na yung deviation variation. Dito naman sa distribution analysis, ito ang 85% first quartile, second quartile, third quartile, at third quartile range. Para makuha mo to, kailangan mo lang na, so 85% kailangan mo lang siyang multiply, ay divide over 100 times ng population kung ilang years yan, times kung ilang export value meron, plus 1. Then makuha mong 85%. Sa first quartile, is equivalent ang first quartile sa 25%. So, kailangan mo siya 25 over 100 times mo sa kung ilan ang export value plus 1. Ganun din sa second quartile, third quartile. Tapos dito sa measures of association, ito ang X value at Y value ang kailangan nating makuha. Para makuha ang X value, yung data mo, kailangan mong makuha yung average data ng export value mo. Hindi, sa X value, Yung data ima-minus mo sa total value. Sa Y value naman, para makuha mo yung single export value minus ng average para makuha ang Y value. Tapos para makuha mo naman ang covariance dito, total ng X value at Y value, dito, since product kami, total ng year export value 1 at year export value 2 ang kinuha ko. And then, i-divide siya kung ilang taon. Minus 1 para makuha yung covariance. Sa correlation naman, type mo lang yung equals, tapos P na may point S, and then multiply the average ng X and Y value para makuha mo ang correlation.